Hey everyone, I am Miss Hu, your physics teacher. In this video, we're going to be learning about circuit diagrams and circuit components. What we'll be covering in this video lesson are the circuit diagrams, common circuit symbols, diodes and their connections, light-dependent resistors, also known as LDR with an example circuit, as well as thermistors with an example circuit. Now, this video will not be going in-depth into the concept of circuit diagrams and circuit components. What we'll be covering in this video is the syllabus content for IGCSE Physics. So of course, if you'd like to know more, please feel free to watch my other videos or do your own research. So before we get started, we all know that Miss Ho's slides are not complete without a meme. So this is not very funny, but I thought it was cute. Anyway, let's get to circuit diagrams. The diagram on the top here shows us a graphic on what a circuit would look like. So this is a very simple circuit with a cell, a switch, and a light bulb. However, when we want to present the circuit universally, we always draw circuit diagrams that look like these. So why we use circuit diagrams? Because they are easier to draw. So if you look at the diagram on the top and the diagram on the bottom, obviously the diagram on the bottom is much easier to draw. The components, that means the bulbs, wires, cell, and so on, have symbols. So we use symbols because they can be easily understood around the world. Regardless of whatever language that we speak or read or write, we use the same symbol so that they're easier to interpret. So for example, it's a symbol of a battery, there's a symbol for a switch, and a symbol of a light bulb. Wires are always drawn as straight lines. We don't draw them whirly, curly, curved lines. We draw the lines straight even if in real life they're looped somewhere or they have to go through weird places and weird corners in a building. We still draw them as straight lines. So this represents one wire. So this way the wires are neater and easier to interpret. Now let's take a look at some circuit symbols which are commonly used in your syllabus. For your information, the circuit symbols I've shown in these slides here are taken from your syllabus guide on page 49. So if you'd like to have the complete list, please refer to your syllabus guide. For now, let's just go through the circuit symbols. So if you can see, for all the circuit components, we always draw connecting wires on either side just to show that they are part of a connection. When we say cell, we're just referring to one. A battery is made up of two cells or more. The symbol of a cell is one long straight line and one short one. If you have more than one cell in a battery, you draw the symbol like this. So in this case, this symbol shows 3 cells placed in series. If there's a lot more, you can draw them this way. The dotted lines indicate there are more cells in between. If you have a general power supply, you can draw it this way. And if it's direct current, you label positive, negative. If you have a power supply, you draw 2 circles like this. So you can think of the 2 circles as representing the terminals to which you will connect the connecting wires. If the power supply is a direct current power supply or DC power supply, you can label the positive and negative terminals. To show that the power supply is alternating current or AC instead, you draw this wiggly line in between. So you can think of this wiggly line as taken from the alternating current graph, which is basically a sinusoidal wave. A fixed resistor normally is drawn as a rectangle like this. For those of you who have learned more about electricity, you might know that a resistor can also be drawn with a different symbol. For IGCSE, the rectangle is a preferred one. If you'd like to know more about the other symbols, I will cover that in another video. This is the typical symbol for a switch. And again, there's actually more than one symbol for a switch. This is the preferred symbol in IGCSE. If you have an earth wire or a wire that's connected to the ground, this is how we indicate that the wire is connected to earth or the ground. If you don't know what it means to connect to earth or ground, I will cover this in the lesson on electrical safety. I'll put a link to that video in the description below. If you have several wires or conductors connected to the same point, this is how you can show the connection. So when you have multiple wires connected to the same point, this is known as a junction of conductors. The lamp or a light bulb symbol looks like this. Again, there's actually more than one symbol for the lamp or light bulb. This is the preferred one for IGCSE. For the motor symbol, it's basically the letter M. Sometimes you might find that the symbol doesn't have this squiggly line underneath. It's just a capital M. As long as you see the M inside the circle, that's a motor. For generators, it's a square with the letter G inside it. The variable resistor looks like a resistor with an arrow through it. So you can think of the arrow as representing an adjustable slider. The thermistor is a rectangle with a slash line through it. A light-dependent resistor is a resistor with 2 arrows on top. The arrows are going inwards because the arrows are representing light. So basically the resistor is detecting the presence of light. The symbol of a heater looks like this. You can think of these vertical lines representing the grills on the heater. We'll be going through the basics of light-dependent resistor and thermistor in the same lesson shortly. This is one of the symbols that are used for potential divider. To know more about potential dividers, please watch my video on potential dividers. I will put the link to that video in the description below. This is the symbol for a transformer. The curved lines on both sides here represent the primary and secondary coil, while the line in the middle represents the soft iron core. Sometimes it may be a single line, sometimes it may be a double line. To learn more about transformers, please watch my video on transformers. I'll put a link to that video in the description below. For a magnetizing coil, this is what the symbol looks like. These curvy lines represent the coil. So if this coil was connected to a circuit, the current will make the coil into an electromagnet. For the ammeter, the symbol is the capital A inside the circle, while for the voltmeter, it is a capital V inside the circle. The symbol for a diode is a triangle with a line, kind of to show the direction of the current that is allowed to flow through the diode. We will go through the basics of diode in this video lesson as well. The light emitting diode is similar to a diode. The only difference is that this component emits light. So you can see that arrows are going outwards from the diode because the light is going from the diode outwards to the environment. A fuse looks like a resistor except the line goes right through. That's because the fuse is made up of a single piece of wire inside that melts when the current is too high. If you don't know what a fuse is, please watch my video on electrical safety. The link to the video lesson is in the description below. For a relay coil, it looks like this. The line is connected to the long parallel section of the rectangle instead of the short ends. To learn more about the relay coil, this is covered in my video on electromagnets. Link to the video is, of course, once again in the description below. The symbol for the electric bell looks like this, kind of like a mushroom. You can think of this half circle as representing the curved top part of the bell. For the electric bell, the two connecting wires are touching the straight line part of this half circle. You might find that there are some other components that also uses a half circle, but the connecting wires will be connected to different parts of that symbol, and that will be for a different component. Now, it also helps if you know the symbols of other circuit components, but for IGCSE, these are the most basic symbols that you must know. Now, for this video, we won't be going through all the circuit components because some of the components are covered in more detail in other lesson topics, which is why I put the links to those videos in the description below. For now though, we'll go through the basics of diodes, light-dependent resistors, and thermistors because it's covered in this section of the syllabus. We will start first with a diode. Now, first of all, you need to know what a diode is. A diode is an electrical component which allows current to flow in one direction only. So you can think of a diode as kind of like a traffic controller. So on the left here, we have several symbols of the diode. The symbol of the diode basically is a triangle with a line to indicate clearly the direction which the current should flow. So you can think of the triangle as representing an arrow that shows us the correct direction in which the current is allowed to flow. That means that for these symbols, the current is flowing from left to right, from positive on the left to the negative on the right. Now you can see that there are several symbols of the diodes, and remember that many electrical components have more than one symbol. If you want to know why the same component has so many symbols, you can think of it as because electricity is used worldwide, many people have come up with their own symbols, and within that region, they were accepted as that symbol. So when we started knowledge sharing, we found there's more than one symbol. In the end, we just accepted many of these symbols to represent the same component. So in the case of the diode, all of them basically have a triangle. Some of them, the line may go through the triangle. Some of the triangles may be filled in like this, or some might be hollow triangles. As long as you see the triangle with the line kind of showing the current direction, that would be the diode. In fact, these are not the only symbols that I've seen. Some symbols also have circles around the triangle instead, like the one on the right here. It's just for IGCSE, we can draw the diode symbols without the circles. Now, a light emitting diode basically is a diode that emits light. It's known as an LED for short. So similarly, there are also multiple symbols for the same component. The symbol basically has arrows coming out of the diode. So you can see that the symbols look almost the same. It's just that the LED has the addition of arrows. And we normally draw two arrows to show clearly that light rays are being emitted. So how do we use a diode in a circuit? Now, the diode is an extremely useful component, but in this video, we'll go through the very basic connection of a diode and how it works in a circuit. When you connect the diode in a way that allows current to flow, this kind of connection is known as a forward bias connection. So an example, as you can see in this circuit here, we have the battery with the positive terminal on the left and the negative terminal on the right. So the current is going to flow from the positive terminal this way. It's going to flow through the wires, and as you can see, the current can flow through the diode following the arrow represented by the triangle. And then it flows through to the other side to the negative terminal. So if we use an LED instead of a diode, the LED would light up. However, when you connect the diode in a way that doesn't allow current to flow, it's said to be connected in reverse bias connection. So you can see in this example over here, we now have the positive terminal of the battery on the right side and a negative terminal on the left side. So let's check how the current would flow. So current will flow from the positive terminal through the wires, and when it gets to the diode, it can't flow through because the diode does not allow the current to flow through. So if this was an LED, the LED would not light up. So a diode is very useful as a traffic controller that allows current to flow in one direction only. If you'd like to learn more about diodes and why we want to control the current this way, I will cover this in another video where I will go into more detail about diodes and their uses. For now, you just need to know about the basic diode connections. If you are ever asked about how the diode should be connected to allow current to flow, remember you say forward bias. And if you're asked about how the diode is connected that prevents current from flowing, that connection is known as reverse bias. Now, let's go through light-dependent resistor, or also known as an LDR for short. So a light-dependent resistor is an electrical component which changes resistance with the intensity of light. The brighter the intensity of light, the lower the resistance of the LDR. The symbol of an LDR is basically a resistor with arrows pointing towards it. Remember, the arrows represent light. Sometimes the symbol may have a circle around the resistor. Now let's go through a very simple example of an LDR circuit. So we have here a circuit with a battery, a fixed resistor, and an LDR. We have a voltmeter across the LDR labeled as V1 and a voltmeter across the fixed resistor labeled as V2. So what is the significance of an LDR placed within a circuit? Now, fixed resistors have resistance which does not change. So an LDR basically is a variable resistor, but the resistance changes automatically. So to help you get an idea of how an LDR may be useful, let's talk about how the LDR can change the value of the potential difference in different light settings. So let's start first with a bright setting. So imagine that there's bright sunlight falling on the LDR, or even if it's just light from another lamp. So when the intensity of the brightness increases, what happens is the resistance will drop. So I'm going to write here R, LDR, which is the resistance of the light-dependent resistor. And this arrow here just represents the drop in resistance. So the resistance has decreased. Now V1 is connected across the LDR. That means the reading of voltmeter V1 is influenced directly by the resistance. So remembering what you've learned using the equation V equals IR, if the resistance drops, the voltmeter reading will also drop. Now this would cause V2 to change as well, because as you can see in this circuit, the only components here are the LDR and the fixed resistor. So using our understanding that the electromotive force from the batteries would be equal to the sum of V1 and V2. So you should know, of course, that EMF is a fixed value, which is the voltage of the battery. So you can see from this equation that if V1 were to drop, this would cause V2 to increase. Now let's look at what happens if it's dark. So just to represent that it's darkness, I've put a moon here. Not really the moon, it just represents night. It doesn't even have to be nighttime. Imagine if it's, let's say, a dark room or a shaded area where there's very little light. So if it was in the dark condition, this would cause the resistance of the light-dependent resistor to increase. This would then cause the voltmeter reading of V1 to also increase. And because we know that EMF is a fixed value, the increase in V1 would cause a decrease in V2. So this is how the light-dependent resistor can automatically change the values of V1 and V2 depending on the intensity of light. This concept is covered more under potential dividers. So if you'd like to understand more about how this works, please watch my video on potential dividers. I've put the link in the description below. I'll also be doing another video where we'll go into more detail about how light-dependent resistors work and what are their uses. For now, we're just doing a simple overview about a light-dependent resistor. Next, we're going to be learning about thermistors, and we're also just going to be learning about the basics. So what is a thermistor? So a thermistor is an electrical component which changes resistance with temperature or heat. The higher the temperature, the lower the resistance of the thermistor. Now in IGCSE, you'll be learning about the NTC thermistor. NTC means negative temperature coefficient. What this means is that the resistance changes in the opposite direction to the temperature. So just like what you can see in the slide here, the higher the temperature, the lower the resistance. In your exam, you do not need to write NTC. It is understood that if you just wrote the word thermistor, it is the NTC thermistor. Are there positive temperature coefficient thermistors or PTC thermistors? Yes, there are, but you will not be learning about them in IGCSE. The symbol for thermistor has a slash through it, or you can think of it as like a hockey stick going through the resistor. For me, I like to think of it as a broken T through a resistor. The T, of course, is to help me remember that it's a thermistor. The word thermistor is a combined word formed from the words thermal resistor. So that's how you can remember that thermistor is related to temperature. So remember that for the thermistor, the resistance changes in opposite direction to the temperature. For example, for a normal high resistance wire, the higher temperature causes an increase in the resistance. For a thermistor, it is the opposite. The higher temperature causes a decrease in the resistance of the thermistor. Now let's take a look at how the thermistor can automatically influence the potential difference of a circuit. Now again, in this circuit, it's a very basic one. We have a battery, a fixed resistor, and a thermistor this time. We have voltmeter labeled V1 across the thermistor and a voltmeter labeled V2 across the fixed resistor. We're going to look at this similar to how we understood the LDR circuit. But this time, because the thermistor responds to heat, we're going to look at the conditions of hot and cold. So now let's say this flame represents a high temperature. So I'm going to write here heat just to indicate that there is a presence of heat, higher temperature. So the higher the temperature, the lower the resistance of the thermistor. So RT here represents the resistance of the thermistor. So the resistance of the thermistor would decrease. Again, similar to the LDR circuit, because V1 is connected across the thermistor, the lower resistance would cause a decrease in the reading of V1. So just like with the earlier circuit, the EMF of the battery is equal to the sum of the voltmeter readings V1 and V2, because these are the only two components in this circuit. So a decrease in V1 would cause an increase in V2, and that's when there's higher temperature. Now, if the temperature drops, so I've got the ice cube here just to represent how cold it can get. So when the temperature drops, I'm just going to write here cold, the resistance of the thermistor would increase, causing the voltmeter reading of V1 to increase. So an increase in V1 would cause a decrease in the voltmeter reading of V2. So that's how the thermistor can automatically change the voltmeter readings or the potential difference of the components inside a simple circuit like this. So just to emphasize, there is more to know about this. This is covered more in my video on potential divider, and I'll also make another video where I'll talk more about the thermistor. So links to those videos will be put into the description below. And that is it for this video. So if you found this video to be educational and helpful, do click like and let me know in the comments below how you have found this video to have helped you. If you'd like to help me keep making free educational video lessons and lab practicals, donations are welcomed at my Ko-fi page. That's ko-fi.com/physicsrocks. For notes, quizzes, and syllabus updates, check out my website at physicsrocks.com. Do watch my videos on other topics on my YouTube channel, which you might find helpful. Subscribe for more free physics lessons from your physics teacher, Miss Ho. Happy studying!